Hello dear students, so you have already seen the regression model using neural network. Now we are going to do another topic on the very common type of problem that we do under neural networks after regression, which is classification. So today's topic involves classification. So the aim that we are taking today is to take up 0 to 9 digital picture recognition. So it's like handwritten numbers from 0 to 9, that data set we have picked up. So we will take 0 to 9 digital picture recognition as an example to explore how to use machine learning or deep learning to solve the classification problem. So the data set that I have picked up is the standard MNIST data set. So what is an MNIST data set? It is a handwritten digital data set which is generally scaled to a fixed size, that is here it is 28 by 28 pixels of image. All of them are uniform, and for simplicity grayscale information is retained. So you have three categories of pictures that we deal with. One is black and white, another is like grayscale, and another is colored image. Okay, so for ease, that because we are just doing it for the initial stage, let's pick up grayscale images and work with it. So these pictures will be used as our input data, which I am terming as X, and also this particular data is labeled in nature. So have a look, this is like how a handwritten digital picture. So like this, large number of images are present. All of them are uniform in size, scaled to 28 by 28 pixels. So this MNIST data set has got real handwritten pictures from 0 to 9, and the total number of pictures that you have in this data set is 70,000, and out of which 60,000 you will be using for training and 10,000 will be used for testing. So you can see this is how an MNIST data set look like. So it has been taken from lot number of people. So that's why you can see, somewhere it is so lightly written, somewhere it is so dark written, and there are various ways in which you can write the numbers also. Everybody has got different handwriting. So it's a labeled data. So however it is written, it has been categorized as a 0, 1, 2, so on up till 9. So it's a labeled data that we have picked up, MNIST data set. Now we are supposed to note a few points, and these few points are important for you in your coming future when you will be doing convolution neural networks as well. So please frame them in your mind. So generally pixel values, they are ranging from 0 to 255. Okay. So in order to express any color intensity information, we use or we juggle between these 0 to 255 values to give you that color or that intensity. Please keep in mind. So for an example, if I am using 0 for any pixel, that means it is of lowest intensity, and if I am using 255, that means it is of highest intensity. So if it is a color picture, then each pixel contains the intensity information of 3 channels. So primary colors are 3, red, green and blue. So if it is a color image, then you will be having 3 channels associated with a red color, green color and blue color, and intensity of each color will be again ranging from 0 to 255. Now these represent the color intensity of the color red, green and blue. So this was about color image. So each pixel of a color image is represented by a one-dimensional vector with 3 elements. Now these 3 elements are going to represent the intensity of the colors red, green and blue respectively. So as a result, if you are saving a color image as a tensor, then you have the dimension of that color image tensor as h comma w comma 3 by 3 default, because 3 is the number of channels. So if it's a color image, you can find it out by this tensor. If you are representing an image pixel with this height and width of the pixel followed by a 3, that means it's a color image for you. And if at all you are using a grayscale image, then you will have only a 2-dimensional matrix, that is you have only h comma w, or if you want to represent that into a 3-dimensional tensor, then you have got h comma w comma 1. So if you don't have enough data and you are just seeing at the tensor value, and if you make out a pixel value say 28, 1, that means it is a grayscale image of size 28, 28 by 28. If it is 28 by 28 by 3, then it will be represented as 28, 3 it's a color image tensor. So in that way you can differentiate between a color image and a grayscale image, and intensity is lowest at 0th pixel and intensity is highest at 255 pixel. This is for your information throughout this course. Now, the matrix content of a picture for number 8 is what I have taken in this example. Now you can see here that all the black pixels in this picture, they are all represented by 0. Can you just zoom in here and see that, one second. So you have got all black area here. So all these black areas, when I map it as a value of intensity of pixel, I am having all zeros here. Throughout the area where I have got all black, you know, this image is made up of grid of pixel. So for every pixel I am supposed to give a value. So if it is black, I am going to give a 0, and for the areas where I am having whites like this, then I am going to give you as an intensity. If it is purely white, then I am going to give that pixel value as 255, or I can even give 200 if it is little low, or I can give 180. So you can see this particular area here has got some values associated like 252, 253, 255 based on the intensity of whiteness, and remaining all the area as per this image where you have black content, all of them are zeros. So the whiter pixels in the picture corresponds to the larger values in the matrix, and the darker picture or blacker picture corresponds to almost 0 values. So this is how a grayscale image is quantified in terms of pixel values. Now, so these are the steps to download, manage and load the MNIST dataset. You are going to import TensorFlow library for it. More in depth about TensorFlow and Keras we are going to see in the subsequent units. So right now giving it a pause and moving on to the meat of this particular steps. So here what I am doing, I am first loading MNIST dataset, which I told is a labeled dataset. So once I load that dataset which is inbuilt in Keras, I get to have all its values in X, Y, and the category gets it gets loaded as X, Y and XVal and YVal. So X, Y is going to be my training data set, and XVal, YVal will be my testing data set. Now once I get that data set, I am supposed to rescale it, because for better processing you require all the values of the pixels to be around 0. In that way the processing will be better. So that's why you have to better convert it into float and rescale it to -1 to 1. So that's what I am doing in this particular step. And then after this, all of these are integer values or float values, and then I am supposed to convert them into tensor. Okay. So what I did here is all my X values I am converting it into tensor, and I rescaled it and I converted into tensor, and also my Y values I am converting it into tensor. So once I get that X and Y, I got my values with me. Okay, input values, the input along with the labeled data that I got for my training data. Now after that, I am using one-hot encoding. Now what is this one-hot encoding? One-hot encoding means, suppose you have got a data and you want to represent it into binary value. Okay, so that is called as encoding. Okay, one-hot encoding, suppose I have 3 datas that I want to represent it in binary information, then I may choose to write it as 001, 010 and 100. Now what pattern are you noticing here is the value of 1 is getting shifted. Okay, every significant place have a unique, the value of 1 is being shifted to every significant place, but it is not getting repeated. I mean, you do not have more than 1, or you do not have 100 for 2 types of data, you know. Every data has got a unique binary value with a significant position of 1 that is keeping on changing. So this particular type of encoding is called as one-hot encoding. So this type of encoding is typically used for our neural network problems. So what are you doing here is your category, the labeled data category of say 0, 1, 2, 3 so on up till 9. That means a particular image has been categorized as 0 or 3 or 9, whatever it is. The output category, you want to put it into a binary format, but that is one hot encoded. So that's what I am doing here. I am converting my label into one hot encoding. So once I print it and I check, I have 60,000 of my training data, and that is now converted into X, and then I have from 0 to 9 labels as output, which are nothing but 10 in number. So I have this Y. So I have 60,000 training data input, 60,000 training data labels, which is my output ready with me. I can even take out some batches and work with it later for training. So I just pulled out a batch of 512 and created a training data set. Now, few things to note here is we use a matrix of shape h comma w to represent a particular picture. For multiple pictures, we can add one more dimension and use a tensor of shape b comma h and w. So what is this b? It is the batch size. So I just took some batch of 512. So that is one batch size that I can even use. Instead of using h comma w, I can choose a batch and then h comma w also. So color pictures if you want to, so that was about grayscale, right? The color pictures can be represented with the shape of what? Batch size, h comma w, and then the dimension of the number of channels. So by default, if it is a color image, it is going to be 3. If it is a grayscale image, it is going to be 1. And B is the batch, H and W are the dimensions of your input pixel that you are giving. Okay, so these things are something which you must note, which is throughout any hands-on that you would be doing using images. So in this particular module, we have started with classification and we tried to see how to classify it first by choosing the dataset which was MNIST dataset, and then we tried to load the dataset. Subsequent steps we are going to see in the next topics.